All right, here we go back with the rest of the slide. Get rid of that. Alt-T. Okay, so we're back on slide 46. So I'll cover this in another video. I'm going to go make some videos out in the shop today. Hopefully. It's kind of hard. My camera kind of sucks, so it's kind of hard for me to actually take welding videos. But we'll see what I can come up with. I'll try to make it kind of interesting. I'm sure most of you guys are more interested in MIG-TIG welding than the other types of welding that I've covered recently, just because we can actually do that in the shop. And so electrode extension. Electrode extension is the amount that the end of the welding wire sticks out beyond the end of the contact tip. I call that the stick out. But a long extension may cause too much filler metal to be deposited, resulting in shallow penetration and spray transfer. If the extension is too short, proper preheating of the wire does not occur. So it's actually pretty cool. What happens is, actually, you know what? I've got a dry erase board. I'll be right back. Because I could have done a little bit of prep for this, but that's okay. Oh. All right. See how poorly I can draw this. All right, so you have your nozzle. All right. Shoot, I kind of need to see my camera. Okay. So here you kind of have your nozzle and your contact tip, and then the wire. Okay. So the distance from the end of your nozzle to the end of your wire is your stick out or electrode extension. Okay. What happens when you're spray welding, which I thought was cool. I just figured this out. If you have the right amount of stick out, okay, when I did my certification test just a couple weeks ago, the stick out was 3/4 to an inch. So I had to hold this nozzle at least an inch away from the workpiece that I was welding. Okay, so then once it starts doing that, it kind of, without even touching the metal, it just shoots it, disintegrates and just sprays it. Okay, which I thought was really cool. And it's actually because from the time that the wire leaves your nozzle to the time it gets to an inch, it's because it happens because the heat coming off your arc heats up that wire enough for it to just melt and spray. Okay, which I know you guys don't have. I'll try to see if I can capture it, but I don't think I have slow-mo enough. But it that's such a short amount of space, and it happens so fast that I don't know. I thought it was really cool. Wow, this dry erase board sucks. But the same happen. The same is true for self-shielded flux core wire too. The heat actually activates the flux inside of the wire, so you have to have the right stick out. Which I don't know. I thought that was cool. Okay, I'm gonna try to turn this off again. I don't know. I don't know if it turns it off or not. Okay. Electrode extension. So here you have from the nozzle to the work distance. Okay. I guess the stick out is from the end of your tip. Usually that tip is only like an eighth inch set into your um, nozzle, so it's not that big of a deal. Welding techniques. Most arc welding processes require the welder to control the following in order to obtain a good weld. Arc length, super important. Welding speed, super important. Gun angles and motions. Um, for you guys that were here during the hybrid, um, arc length was the most important part of stick welding, probably. You can you have a wider range of like degrees that you can use for gun angle and motions, and your welding speed can vary a little bit. But arc length is so incredibly important. Welding speed affects the bead width and penetration. So if you go faster, it's going to be narrow. If you go slower, it's going to be fatter. That's because you're adding more or not as much. More than one pass may be required to fill a weld groove. Hopefully, we'll cover that. There's very few things I find as enjoyable as running a vertical up butt joint with a Z-weave. You can just make it look real good. It's like, I don't know. If you get good enough, it just looks really good. And backhand welding gives the best penetration. So, okay, I'm going to try to draw backhand welding. When I was in school, I was taught simple phrase: if there's slag, you drag. Okay, so let's see. You have your workpiece. Okay. Motion. So here, this is kind of, oh, shoot. So here, you have your workpiece and your gun, and you're moving this way, okay? You can see that this wire is being pushed into the back of your weld pull, okay? That would be considered backhand, okay? To make it not backhand, it'd be going the other way. Sorry, I tried drawing a MIG gun. So backhand is so I don't know. I don't know if they call it traditional or not backhand. Just not backhand. Okay. You're pushing it, so your wire is going into the leading edge of your weld pull, and is facing not weld. Okay. So with backhand, your wire is going into the back of your weld pull, and your wire is angled towards the weld you've already put down. Not backhand is your wires facing the workpiece. If that makes sense, okay? Sorry, I'm kind of a bad artist, so man, this thing is junk. All right. Let's go ahead and cut this off again. I really hope that doesn't get rid of my voice. T. Running bead work to keep the edge of the bead straight and the nozzle a constant distance from the base metal. Maintain a constant travel angle. Adjust travel speed to produce a bead that melts into the base metal at the toes of the weld and has proper width. All of this is just stuff that you'll have to kind of look at and read the puddle as you're welding. It's a learned skill. I mean, it's something that you'll just have to kind of get used to. Like by now, I don't even pay attention to anything but the weld puddle. Like, it doesn't matter like what I'm welding. It's just I read that puddle and I've seen it, 10,000 times. I know exactly how it should look, and I do everything I need to keep it looking the way I want it to look. Okay. Weaving creates a wider and flatter weld bead than a stringer bead. So here we have like a Z-weave, go up, over, up, over, up, over. That's what I like to do. If I'm TIG welding, and I do a weave bead, I kind of do the W just because I think it looks nicer. If I'm doing just like a regular stringer bead, I just do the ovals. It just depends on what size weld you need. Stopping and restarting a weld bead. Do not fill the crater if you are not at the desired end of the weld. We'll actually cover this in another video. Shutting down the station. You got to close all your valves to shut off your gas. Drain the shielding gas from the system, which you don't really need to do that. Turn off the wire feeder, turn off the welding machine, coil the cable and hang up the gun, and coil the ground clamp or workpiece cable and hang it up. Not most of the time, we probably won't in the class. We won't take off the ground clamp just because there's no need to in our work booths out there. The next person is just gonna have to put it back up. Working in the industry, I'd say most of the time, you're almost always gonna have your own like specific table that you work at or workstation. So it'll be only you working on that table unless somebody comes in after you to work on it. But even then, I've always thought it was kind of dumb to like fully wrap up your machine at the end of your day. Then the person coming in behind you has to take the time to unwrap it. So it's a waste of time to me. But some places have you do it, some places don't care, and then some places you'll have your own table that nobody else uses. So it's more preference. Joints in the flat welding position. So I'm going to cover this in a video out there. I'm gonna make one of each welding joint. I'll probably go over this as we go through it. Horizontal, vertical, overhead. Automatic. So MIG and flux core can be semi-automatic or fully automatic process. Guns can be mounted on a motor-driven carriage or robot, and the process is fully automatic when the welding gun is controlled by a machine with feedback controls. So that could just kind of tell the machine if it's doing it right or not. Gas metal arc spot welding. You can spot weld like sheet metal. It's not as good as like the resistance welders where it pinches it and it heats it up. But you can do it. A spot weld is a weld made at a single point on an overlapping pieces. Weld time is controlled manually or by welding power source with the timer controls. Gas metal arc spot welds on thin metals can be made in any position, and thicker metals are welded in the flat position only. Troubleshooting guide. When troubleshooting, first identify and check the items that are known to cause a problem. Ground clamp, the ground clamp is probably the biggest one. Sometimes those can work loose and they're not making good ground or, whatever. Your wire feeder, make sure that it's not bird nested. Make sure that there's the right amount of tension on it. Make sure that you have the right contact tip, stuff like that. Next, check the equipment setup and welding technique. And finally, check more difficult items such as worn cables, grounding issues, and problems with design of the weld. I wouldn't say grounding issues would be a difficult item to check. But, okay. Safety. Wear a helmet with approved lens to protect your eyes and face from arc radiation. Wear PPE to protect against radiation and burns. Wear clothing made of flame-resistant materials. And weld in a booth or shield the welding area to protect others. It's pretty important to have a welding hood with the right lens. Otherwise, your eyes do get pretty fatigued, and you'll kind of, feel tired more. And you definitely don't want to have just a half mask on and burn your face up. Wear PPE to protect against radiation and burns. That's it's the same as for stick and MIG and flux core. It'll burn you pretty quick. So no holes in your jackets or nothing like that. No exposed skin. flame resistant materials, MIG and flux core, they do spatter kind of a lot. You can get spatter in your sleeves and stuff, which if you're welding out of position and you're like hanging over something and you're welding one-handed and you have a bunch of spatter roll down your sleeve and land on your elbow, it's pretty uncomfortable. Do not weld in wet or damp areas. Duh. There's a massive amount of electricity going through them workpieces. Do not touch energized parts of the welding gun with bare skin or wet gloves. The wet gloves is probably the one that'll get some people. Most of the time you're working in a shop, it's going to be really, really hot. You're going to sweat a lot. Your gloves will kind of get soaked. I always like to have 2 pairs of gloves if it was like real hot in the summer. That way I could be working. One pair of gloves start getting a little bit too wet, I can set them off to the side next to a fan or, somewhere out in the sun, let them dry out, switch to my other gloves, and flip-flop. Arc weld only in well-ventilated areas. You really don't want to be breathing in anything that's not oxygen and air or whatever. Most of the welding gases are going to be heavier than oxygen, so they're going to fall towards the floor. You definitely don't want to be welding overhead and have all that argon just fall on your face. You won't really notice it for a while, and your body will kind of work its way out. But if you fill up your lungs, you can actually drown in argon. Use ventilation and or filtering equipment as needed. Small clogs are pretty good, which we have those vents in every booth, which is adequate. Take steps to avoid breathing carbon monoxide, ozone, or other harmful gases. Again, we're not going to put our faces right next to the weld area or, blow the gas in our mouth. Do not weld on any base metals with chemicals on them. That's pretty important. Little side note: I was building this like awning thing for this hospital in Rensselaer, I think, and it was just it was like an 8x8 aluminum tube, and I was cleaning it up real good, getting ready to weld it. Because aluminum has to be like super clean to weld it correctly, and it being a structural thing, I had to make sure it was real clean. The welds were going to be awesome. So I squirted a bunch of acetone on it, the inside, to clean up the inside for penetration, so that the weld wouldn't suck contaminants from the backside of my weld into my weld. And I didn't think anything of it, and I started welding on it, and all of a sudden there's this huge boom. Okay, well, the heat from the arc actually ignited the acetone inside of the tube, and it was like a giant air cannon. Luckily, nobody was hurt. There was nobody there working around me that day. At the time, I had my own little area, well, pretty big area for this other project that I did. So nobody was around it, but there was a really big fireball that came out the end of this 20-foot tube, and it was just it could have been extremely bad. It probably could have killed somebody if somebody was standing at the end of the tube. I didn't think about it, and so I'm glad nobody got hurt. But that's why you never weld on anything with chemicals on them. You don't know how it's going to react. You don't want to catch your friend on fire or some passerby. There's a giant fireball. It could bake the inside of their lungs if they're breathing as they walk by. Clean metals that previously had chemicals on them or on or in them per codes prior to welding. Wow, that was a brain fart on my end. Treat all metal in the welding area as if it were hot. Use pliers to handle hot metal. Again, like I've been pushing since day one, safety. If you're out in a weld shop, don't touch anything with your bare hands. I don't care if you know it's cold. If it's metal, don't touch it with your bare hands, okay? Hand injuries are like the number one injury for a welder, or common injury. Was that it already? I gotta just finish this out since I skipped most of it. All right, so this is gonna be a 2-part video. So hopefully you watched the other one. I'll upload some more videos too. I'll go through and cover all of the. I want to cover the the actual welding part out in the shop. I don't want to cover that in a PowerPoint, since I can, actually show you what it's talking about. All right, so make sure you watch out. Yeah, sorry, I didn't mean to pause that. So make sure you watch out for those videos. Watch those videos. Let me know what you think. I'm sure they're going to be kind of iffy. My camera is kind of garbage. So, but we'll see. All right, see you guys later.